Researchers at NASA's Goddard Space Flight Center in Greenbelt, Maryland, have discovered X-ray activity that sheds light on the evolution of galaxies. The X-rays outline giant clouds of cold gas in the nearby spiral galaxy NGC 4945. The gas appears to have blasted through the galaxy after its central supermassive black hole erupted some 5 million years ago. There's ongoing debate in the scientific community about how galaxies evolve, said Kimberly Weaver, an astrophysicist at Goddard who led the work. We find supermassive black holes in the centers of nearly all Milky Way-sized galaxies, and an open question is how much influence they have compared to the effects of star formation. Studying nearby galaxies like NGC 4945, which we think we're seeing in a transition period, helps us build better models of how stars and black holes produce galactic changes. Weaver presented the results on behalf of her team at the 243rd meeting of the American Astronomical Society in New Orleans on January 11th. A paper about the finding is now under review by the Astrophysical Journal. The work was made possible thanks to data collected by the ESA, European Space Agency satellite Newton X-ray multi-mirror mission, with help from NASA's Chandra X-ray Observatory. NGC 4945 is an active galaxy about 13 million light-years away in the southern constellation Centaurus. An active galaxy has an unusually bright and variable center powered by a supermassive black hole that heats a surrounding disk of gas and dust through gravitational and frictional forces. The black hole slowly consumes the material around it, which creates random fluctuations in the disk's emitted light. As with most active galaxies, NGC 4945's black hole and disk are shrouded by a dense cloud of dust called a torus, which blocks some of that light. The cores of active galaxies can also drive jets of high-speed particles and generate strong winds containing gas and dust. NGC 4945 is also a starburst galaxy, which means it forms stars at a much higher rate than our own. Scientists estimate it produces the equivalent mass of 18 stars like our Sun every year, or nearly 3 times the rate of the Milky Way. Almost all the star formation is concentrated in the galaxy's center. A starburst event lasts between 10 and 100 million years, ending only when the raw material to make new stars is depleted. Weaver, NASA's project scientist for Newton, and her team looked at NGC 4945 with the satellite. In their data, they saw what scientists call the iron K-alpha line. This feature occurs when very energetic X-ray light from the black hole's disk meets cold gas elsewhere. The gas measures around -400 degrees Fahrenheit or -200 Celsius. The iron line is common in active galaxies, but until these observations, scientists previously thought it occurred on scales much closer to the black hole. Chandra has mapped iron K-alpha in other galaxies,